Professor Monty, let's look at an application or a word problem dealing with exponential functions. All right, so they give us the problem. It says the population of bacteria is doubling every 20 minutes and can be modeled by the function p of t equals 1,000 times 2 raised to the t divided by 20. Now notice the variables in the exponent, that's what makes it an exponential function. Okay, the first part says find the population now, t equals 0, in 10 minutes, 30 minutes, and 60 minutes. So I've laid out how we're going to calculate it. So p of 0 is just 1,000 times 2 to the 0 over 20. Notice I put that parentheses around the exponent. If your calculator already puts it up into an exponent, you don't need the parentheses, but it's not going to hurt otherwise. If it doesn't, if your calculator doesn't put it up as an exponent, you will need the parentheses. Okay, so I've done all these on my calculator. So the first one, notice this is just 0 power 2 to 0 is 1, so that's just going to be 1,000. So right now we're starting at a population of 1,000. After 10 minutes, I'm going to get rounded to the nearest whole number, 1,440. After 30 minutes, I get 2,828. Notice it doubled from this. And then after 60 minutes, I get 8,000. All right. So that's my answers. If you're having trouble getting the answers, I put the syntax to find this last one, the 8,000. What we do is we go 1,000 times 2 raised to the power. Now my calculator raised to the power looks like this. They call it a caret. Some calculators will be y to the x. Some will be x to the y. Make sure you know which your button is to raise to the power. And mine doesn't raise it up into the exponent, so I have to put the parentheses around. So this 60 divided by 20, I actually put it in as parentheses 60 divided by 20, close parentheses equals, and then I'll get my answer. Notice I didn't put a parentheses here. You can if you want to. Some calculators, if you have the parentheses, you need the times. Sometimes you don't, so that's why I just put times. This is exactly how I put it into my calculator. All right, make sure you do that, you get the 8,000. When you plug in the 30, you get the 28 point something. All right, so we've got our numbers. We've answered A. Let's answer B, which would be, I didn't write it up here, but graph the function. So let's see. At 0, I'm at 1,000. So at 0 minutes, so I'm here, I'm at 1,000. See, we're going up to 8,000, so let's go 1, 2, 3, 4, 5, 6, 7, 8. All right, so we're going up by thousands. All right, so at 0 minutes, I'm at 1,000, so I'm right here. At 10 minutes, I was at 1414, so I'm almost halfway between the 1,000 and 2,000. After 30 minutes, I'm up at 2828, so that's almost to the 3,000. And then at 60 minutes, I'm at 8,000. So at 60 minutes, I'm up at 8,000, I'm up here. And notice this has that typical exponential graph shape where it starts off slowly and then it grows faster and faster and faster. So that's my graph in this case. It's an exponential graph. It fits the model, and so I just plug the numbers in. Make sure you get the syntax in. Make sure you can get these numbers in your calculator, and then just go to the graph and graph them. From there, it's pretty straightforward.